All right, so in this video, we're going to do some easy questions of solving trig equations, and we're going to solve them between 0 and 2 pi. So typically for these questions, you want to do your cast rule. In this case, I'm going to use my cast rule. I know that cos is positive in these two quadrants, which means cos is negative in these two quadrants. So I'm going to start by drawing that out. And then you can either find your solution by using your special triangles, or you can just do the cos inverse of -1/2 in your calculator. I'll be using my calculator for this video, but technically you can solve most or maybe even all of these problems without a calculator. So I get 2 pi over 3 when I do the cos inverse of 1/2. That's basically this obtuse angle here, which is my first solution of theta. So my first solution for theta is 2 pi over 3. I know that my small angle beta is pi minus 2 pi over 3, which is just pi over 3, which makes this pi over 3 as well, which means that my second solution is just pi plus pi over 3, which is just 4 pi over 3. And these are my two solutions to this question. Let's go to the second question. Tan theta equals to 1. So again, I want to use my cast rule over here. I know tan is positive in these two quadrants, so I'm going to draw it out. I'm going to do the tan inverse of 1 in my calculator, and I get pi over 4. So my first solution is pi over 4, which is basically this right here. That's my theta and my beta. Then my second solution, I'm going all the way around, so pi plus pi over 4, which is just 5 pi over 4. Okay, let's go to question number 3. This one's slightly harder, but almost the same difficulty. 2 sine x plus root 3 equals 0. I want to start by isolating my sine x, so I'm going to move the root 3 to the other side. Then I'm going to divide by 2. And now I can do my cast rule again. And I know that sine is negative in the bottom two quadrants. So now I'll do the sine inverse of negative root 3 over 2. And I get negative pi over 3 in my calculator. That's just giving me my related acute angle, which is pi over 3. So now I have to find both my solutions. My first solution is just pi plus pi over 3, which is 4 pi over 3. And my second solution is 2 pi minus pi over 3, which is 5 pi over 3. Fourth question, pretty similar to this one. 2 sine x plus 1 equals to 0. I'm going to move the 1 to the other side. So 2 sine x equals negative 1. I'm going to divide by 2. So sine x equals negative 1 over 2. Again, this is similar to this one. I know that sine is negative in the bottom two quadrants. I'll do the sine inverse of 1 over 2 in my calculator. And I get negative pi over 6. So I know my acute angles are just pi over 6. Then my two solutions, pretty simple. Same thing, pi plus pi over 6, which is 7 pi over 6. And 2 pi minus pi over 6, which is just 11 pi over 6. Okay, next question. is 2 cos x equals to root 2. Again, an easy one here. So cos x is just root 2 over 2. I'll do my cast rule. I know that cos is positive in these two quadrants. I'll do the cos inverse of root 2 over 2. I get pi over 4. So I know that pi over 4 is my acute angle, but it's also my first solution, which is in quadrant number 1. My second solution is 2 pi minus pi over 4, which is just 7 pi over 4. Sixth question, this one is slightly different. We have cos x plus 1 equals to 0. Then we get cos x equals negative 1. And now I cannot solve this using my cast rule, because anytime you have a 0, 1, or negative 1 for sine or cos, you have to solve it from your graph. So my cos graph looks like this: 2 pi, pi, pi over 2, and 3 pi over 2. Bottom here is negative 1, the top is plus 1. So where's cos x equal to negative 1? That's down here, and the value of x is just pi. Next question is going to be a reciprocal question. So sec beta equals 2. So anytime you have a reciprocal, you want to convert it to the original. So cos beta equals, flip the other side, 1 over 2. And then it's just your cast rule. So cos is positive in these two quadrants. The cos inverse of 1 over 2 is just pi over 3. I know that my first solution is just going to be pi over 3. That's in my first quadrant. And my next solution is 2 pi minus pi over 3, which is 5 pi over 3. We have another reciprocal question here. So cosec alpha equals to negative 1. The reciprocal of cosec is sine. So sine alpha equals 1 over negative 1, which is basically just negative 1. So again, we cannot use cast rule here. This is the one we got to use the graph for. Remember, 0, 1, negative 1 for sine and cos, we use the graphs. This is what a sine graph looks like. That's 2 pi, that's pi over 2, and that's 3 pi over 2, negative 1, positive 1. We know that when sine x is negative 1, x is just 3 pi over 2. Okay, the ninth question is pretty simple, so I'm going to skip that one. It's the same rules. I'm going to go to the 10th question, which is a bit more difficult. So tan square beta equals to 1. So now we have a squared over here. When we square root both sides, we are going to split it into two different equations. Tan beta equals to positive 1, because the square root of 1 can be positive 1, and also tan beta equals negative 1. So two possible solutions here, or two possible splits, which means 4 solutions in total. I'll use my cast rule here. Tan is positive in these two quadrants, and tan is negative in these two quadrants. So now I'll do the tan inverse of 1, and that's just pi over 4. So in this case, my first solution is just pi over 4, and my second solution is pi plus pi over 4, which is 5 pi over 4. and I do the tan inverse of -1, I'll get my acute angle to be pi over 4, which means that my first solution in this quadrant is pi minus pi over 4, which is just 3 pi over 4. And your second solution is 2 pi minus pi over 4, which is 7 pi over 4. So in total, we have 4 solutions in this question.